Okay, let's begin. Hello, this is Grant Winker with CARLSON Software Mining Division. I'd like to take some time to show you the new 2014 geology and mining commands. And welcome to the webinar. On the dialog box, you'll see a location where you can enter in questions. And in between these topics, I will take a moment and answer any questions if you type them in between. So I'll just kind of go through the list of new commands that relate to geology, surface, and underground mining. We'll start kind of slow while we let people log in at the very beginning here, and then we'll pick up speed as we go down these topics. For the new geologic additions, we've added just some additional features for labeling. We do multi-line leaders and text now, so you can group your text, strata, and attributes differently as before. One of the big features is the graphic drill hole report, and that's a brand new command to prepare, also called a borehole log. It's a paper log that shows the geologic column. And so I'll go ahead and open up a drawing that works for that. And in this drawing, I just have one drill hole, and we'll report that out in a borehole log. So I will switch over to the geology module. And these new reports are found under drill hole down in the reports section. I'll run the graphic drill hole report, brand new for 2014. Select the drill holes. You can pick more than one. I'll just grab this one in this drawing. Hit enter. And you've got options for the sheet size. You can bring in your own company logo if you have that. You can go ahead and edit this block drawing and modify it to your specifications. The vertical scale will control basically how many pages it's going to span because it sizes the height of your geologic column. And then there's 3 tabs down below for your header, the main body of what's being displayed, and then your footer. So I'll just go ahead and take the defaults here. I added ASH and BTU. We've got the description, the different hatches and layers are all set in defined strata, and we'll look at that. Choose OK, and you get a little preview of the size, and you can tell how many pages it will be. I'll go ahead and drop it into the drawing, and then you can plot this out on a laser printer or a color plotter. So now zooming in, you see there's the title, and all that text was set in that report window. The one thing we didn't look at, though, was the hatching and the coloring of the different types of strata and seams down below. They're nicely labeled, and depths, thicknesses, and then any additional attributes are showing up on the right-hand side. So if this was a coal seam, there you see the ASH and BTU values over on the right. So the only thing that's missing to show would be the define strata command is a prerequisite to do that report. And this just defines all the different colors. So let's go and find the slate, for example, and I'll edit that. And that was set to be green. You can control your hatch pattern scale, and then you have several pages of geological hatch patterns that you can apply then to the various strata. We've added some new ones in 2013, and they appeared towards the end of this list. Okay, so that's the new graphic drill hole report. It prepares the borehole logs like you see there. So I'll go ahead and just cover these ones I've highlighted in yellow. That was the graphic drill hole report. Another new one that's been asked for quite a while is better reporting on splitting seams. So if you've got a main seam that splits into two, some people call it parent and children splitting. We've added some options to surface mine reserves now to automatically report those out with no user definition of areas and boundaries. It's just all automatic based on departing or interburden thickness. So let's go ahead and take a look at that. I'll go to the splitting drawing I've prepared. And it's a very simple case where I've got a full seam on the north side here. So if we look at a drill hole, we'll consider this C2 seam as the full seam. That's the parent. And so on these northern holes, they're all full seam. Down below on the south, we have it split into two. There's the C2 upper, the the parting and the lower. And so we've always been able to correlate and model that properly. Just with the defined strata, again, I'll go back to defined strata, and for this drawing, it's a different file. The typical definition is the C2 parent is defined to split into the C2 upper and C2 lower. Now that's not new, that's always been there. That way it correlates the roof and floor of the C2 parent to split into these smaller children's seams. What's new though is we would model this the same as always where it's split everywhere. But then when you run surface reserves or you do any other model analysis and even fence diagram, it automatically joins them back together based on the parting thickness. And so I'll prove that with the pre-calculated grid definition. So this is the model, the geologic defined pre-calc grids. I will open up the split. And inside, all we have is the two children's seams. There's the C2 upper, the parting or the waist between them, and the C2 lower. I don't have the C2 full or parent defined anywhere in this model, which is the way it's always been. But the new part then is all automatic in the background when you run surface mine reserves. So I'll go to StrataCalc, surface mine reserves. The program will see that I've got the split defined, and they're defined in the pre-calculated geologic model. So I'll just hit OK. Grab that split pre-calculated model, and I'll just grab this inclusion boundary, this white or black rectangle that covers both areas. So I should get about half and half based on the area you see. Enter, no exclusion, and I'm up to the report formatter now. And we'll go ahead and look at the strata, the tons, the volume. We'll look at the area, and that should be about it. We do have quality there as well, but we'll go ahead and leave that alone. Display on the report brings up, let's go ahead and exit there and turn off the strata total. I want to do just a grand total and save. So I get one total now. This is that white rectangle. And let's take a look at the C2 seam. So here, if I highlight all of the C2, there's the new option. It tells you the C2 parent contains 221,000 tons. And that's about 20 acres of area. And then it sees the C2 upper, parting, and lower split. Covers 16 acres, and it's about 180,000 tons. So that's the new feature. It's been asked for a while. It's really automatic. It's very easy and simple. So you can now automatically report out parent and children seams together just by putting your splits into the pre-calculated model. Now, based on how big this model would be, there's another huge improvement. Let's take a minute and see if we have any questions. Has anybody asked any questions yet?
No, there have been no questions so far.
Perfect. Okay, we'll move on then. On the same topic is surface mine reserves. They've improved the speed 3 times faster. So if you've had some large area surface mine reserves that maybe take minutes and possibly hours to run, they're now 3 times faster. And they've also added some options for modifying your precision to go even quicker yet if you just want a rough estimation, not the most exact estimation, but just a rough calculation on a large area in a fast amount of time. So it's hard to show that if you didn't know how fast this reserve ran before, but I'll go ahead and open it up one more time. And the new option for the precision is shown here on the right. You can just choose low or high. I usually just leave it at high unless it's taking too long. I just need a rough number. So if I hit OK, I'll just do it one more time. Choose the pre-calculated grid model, select that boundary, and then it's almost instantaneously popped up to the report formatter. You know, maybe in previous versions that might have been a pause of several seconds. I can't say for sure, but at any rate, it's 3 times faster, so that'll help out. Okay, moving down then in the geology commands. That was the parent child. Yes.
Grant, one question. Can you set parting THK Does parting get used in tonnage calcs?
The question would be referring to the split. So they want to know if the parting thickness is part of that tonnage calculation. So let's go back to surface mine reserves. We have this minimum mineable parting thickness. So the answer to the question is yes, it is in the tonnage calculation. I'll put in 0.5. I will allow up to ½ a foot of parting to be mined with the key, the tons. So I'll hit OK. Choose that. Select the inclusion. We do have the display. And here is the parting, C2 parting. It's anywhere it was less than 0.5 has now been included here in the key tons column. And vice versa, if you gave it a minimum coal thickness or key thickness to mine, that would be put into the waste column. Okay. Back to the list. Next one we have highlighted is calculate variogram. This is a command we've always had, but it was broken into 2 sections, and it wasn't very closely linked with the strata calculation portion of the menus. So we've rewritten that, and it has a new interface, and it's just now 1 command as opposed to 2. So I'll go ahead and just run that. We can do it in the same drawing. It just uses any drill hole configuration. It's found under Strata Calc, calculate variogram. So for those of you who are going to be doing kriging, the same command will apply to 2D and 3D kriging. Our 3D kriging would be used in the block model. The 2D kriging is used in the making of grids. So let's say we want to analyze the C3 seam here. I'll hit OK. Then you just choose a value to process. I'll choose the thickness value. And so this is about the same window we had before, but we've got the standard variogram types in the top left. I'll choose number of legs of 50. We'll just hit graph. And so there you can see the data points out in the window, and then it's a best fit to find. Optimally, you're looking for your nugget, your sill, and your range. And so maybe bring up the nugget a little bit on the left. And then these would be the parameters that you bring into the kriging dialog box when you're prompted for the nugget, sill, and range. We can also change the model to exponential and Gaussian just to modify your curve a little bit more. But if you remember in the previous versions, if you had used this, then you had to prepare a kriging variogram data set, and then you would come into this window and you'd have to load it, and then it was a little bit more involved. But now it's much more user-friendly. So we'll go ahead and exit there, and it's ready to do the next parameter. You can do different variograms for the different parameters of each seam. Next one. Kind of a small minor command, but it's pretty powerful actually. It's compare strata to model. This looks at surfaces and drill holes. And so let's say you were maybe given some surface grids from an external source, and you wanted to compare them to the drill holes very quickly and easily to see how close they matched. This is a useful tool for that. Another use would be comparing the drill hole collar elevations versus the surface topography. That's a report we've always had, but this one is very similar. It works at the subsurface level. And so I'll go ahead and use that same drawing since it has drill holes and surfaces already created. This one is also in the drill hole reports section. We'll go down to drill hole reports, and it's the new command, compare strata to model. And you give it a tolerance. So I'll use the report formatter to export it out to Excel as an example, but we'll give it a tolerance of, say, 0.25. This will be feet or meters. And it could be thickness, it could be elevation, it could be any chemistry attribute that you're comparing. So I'll choose all of the drill holes. And let's go ahead and choose that same C3 seam. And we'll just consider the bottom elevation. We'll compare that with the drill holes themselves. select that seam. Here's the C3 elevation. And then the report formatter appears where we can then move things from left to right. We'll move them all over, and we'll take this out to Excel just to view the data. So of those 12 holes, it looks like 5 of those are over the 0.25 tolerance that I entered in. And it tells you the drill hole name, the coordinates, X, Y, and Z. And it tells you what the model, the surface has, and then also the drill hole itself. So it just gives you a check to see how close they all are, and lets you decide if you need to go and remodel. Okay, any questions so far again, or should we move on?
No questions right now.
Next topic, we looked at the speeding up of surface mine reserves. So that one has been looked at, and also the precision. So another huge improvement is in design bench pit. Now this command is in continuous improvement mode. Every version it's getting better and adding features to it. And so for this version, they've added options to suspend the bench or to pinch the bench width down to 0 thickness as it intersects the road, the automatic ramp or road generated when you build the pit. In addition to that, they've added an option to put the berm automatically onto the side of the ramp or the road, which has never been done in the command itself. It was always done as an external portion of the civil or road network. So now it's all included in the surface mine design bench pit. So let's go ahead and try that. Design bench pit. And all I'm starting with is an inclusion perimeter, this white line, and we're going to cut the pit down and in from there with benches, and I'll pick this corner as my road or my ramp starting point. This command is found in the surface mining module, so I need to switch over, choosing the haul truck icon, and we'll look under the surface pull down. Design bench pit brings up several dialog boxes. So the first screen is where you choose the existing ground surface and the pit bottom, what we're going to dig or cut down to. This was an improvement, I believe, in 2013, if you haven't seen this yet, that you can use tin files in your design bench pit, because when you're cutting these benches and toes and crests and high walls and ramps, a grid tended to round off the corners, whereas this tin is much more accurate and it captures those changing slopes very, very well. And it also then would create an output tin surface. If you start with tins on the input, you're going to get the tin on the output automatically. And you can mix and match too. You could have a tin for your topography, and you could go down to the grid of a seam as an example. All right, so we're going to go down and in. And anytime you do the road or the ramp option, you have to go with the offset. That's a default. We'll put in our road width of 100, 10% slope. And here are some of the new options. It's the bench stop distance. I have it set to 200. The bench taper is 400. And these are just basically widths or lengths that you can see from plan view, and I'll show you those. The berm height, I'll just put in a 5. This is in feet or meters, 5-foot tall berm. Of course, when you're going down and in with the road, you got to choose one direction, either clockwise or counterclockwise, and this time I'll go with the clockwise direction. I'll choose a different color for my ramp or my road. And then it draws the break lines on 2 different layers, pit side and pit. Okay, that's the first page. And then we hit OK to get to the next screen, which is your template of your slopes, your angles, your bench widths. And so I'm starting at the top, and I'm going down to elevation 4380. And then I'm going to run a series of 40 tall benches. Then I'm going to hit another tin file. You can use tins to bench to. And then I'll go down to the bottom. All my benches will be flat at 0 slope. They'll be 50 wide, and you can give them names. So once you get this spreadsheet all defined, you can preview to see how it looks. So this is exactly what we've defined in. This must be that tin surface, and then down to the pit bottom. So we hit OK and run it. Follow the prompts at the command line. It says pick polyline. This is the pit boundary. Pick starting point for road. I'll just go ahead and endpoint snap to that corner. Wait a few seconds while it builds in 3D. And then it's going to output a final surface. I'll just call this the final pit.tin and replace it. So if you've worked in this command before, you've probably seen where as the ramp or the road comes down, it steps out to 90 degrees based on the bench width and then continues on down. But the nice improvement here is it keeps the ramp or the road in a nice smooth fashion as it goes down around the benches. This is your volume report screen that comes up every time. It just gives you bench by bench volume, and the overall total here is 91 million cubic yards. But now let's take a look at this in 3D. We can do AutoCAD Orbit. And that taper that you saw, there was, I think, a 200 and a 400 distance. That's referring to this amount. It's a little easier to see when you're in plan view looking straight down. You can see how this bench has 50-foot width here, and then it begins to taper down to 0. You want to make sure these slopes all stay the same. You don't want to have your changing slope on your high wall, so it's very, very unique how it does it now. And then the berm itself, I guess we could look at that in 3D. Let's go to the other CARLSON 3D viewer. I'll go into View, 3D viewer window. And we'll just do a crossing window to grab the contours and the 3D pit break lines. Okay, this has changed also for 2014. For those that use this viewer, it's now similar to AutoCAD Orbit and Google Earth, where you push it up to lay it flat, and then you go to the edge and rotate it around on the Z-axis, and then press your wheel to hold. But the main difference there is the flattening in the X direction is now similar to standard Google Earth and AutoCAD Orbit. So zoom in on the edge of the ramp, and you should see there it is, the berm, 5 feet tall. We told it all the way on the outside. Completely automatic. And then you can see a little better here how the benches taper down to keep that road in a consistent alignment. A couple other things that are new here in 2014 would be surfaces. So I came in and just loaded up the line work.
Grant, one question. Could you make 2 or more ramps simultaneously?
No, the question would be 2 or multiple ramps at the same time, and the answer would no, but that would be something we should look at. Maybe have some polyline alignments where you could just pick the lines and say, here are the ramps to go down. We could go down and do switchbacks. Obviously, if I went down just halfway and stopped, and then started again and went counterclockwise, I could have the ramp come back another direction, but that would be running the command 2 times to do that. We'll have to look into adding that. One new feature, several actually, is the Model tab in this 3D viewer window. And what's kind of nice is that you can combine this line work from the drawing with now surfaces, and there's also ways to edit those surfaces. So let's go ahead and add. I'll bring in the topo tin. I'll do topo tin reduced. But now it's at the same elevation as the contour, so you can't see the pit down below. And what's really impressive now is we can do the transparency. I'll change the transparency of that red surface topography so that I can see through it. Now it's still on screen, but you can see through it and what's below. And I'll go ahead and add one more surface. I'll add the next surface, which I'll do that halfway down. We did the top seam tin. And you can change the colors on those. If you don't like the yellow, I can just right-click, edit surface. You can set its color here. And also then, if you want to see through that one to see the pit floor, I'll change its transparency. So this screen is also improving most every version, and adding surfaces and transparencies is an improvement, as well as line work. You can now freeze inside of these entities. I can go into polylines and freeze the contour if I don't want to see those individually, get rid of them. Okay, so that's design bench pit. They also added the same to the opposite command, design fill surface, where you would build a stockpile with benches and the ramp. It's basically the same thing, so I won't show that here, but it's just going up with the ramp and the berm. Next command we'll look at is the range diagram command. This was new for 2013, if you've seen that. However, it was fairly limited. It was just simple sidecast. And so let's go, this could be run from any drawing actually. I'll find the command under surface. And before 2013, the range diagram command was a cross-section based command. That was quite old, and we improved it in 2013 with this kind of user interface. But now in 2014, we've added 3 other digging methods and a lot more feature and functionality to it. So if you haven't seen this command at all in 2013, I'll go ahead and start from the beginning. You set up your initial cut and pit width. So that would be this is the open existing pit, and this is the future cut, 150. Everything's labeled up in the preview. You set up your initial spoil angle in degrees, and you choose your drag line down below. There's a list of about 40 drag lines included with the program. These are the same that are used with the cut in place, and you can also add your own to this list. And then you start by adding the different seams and drag lines down below. So I'll just hit the first Add Strata button. And it instantly added a default thickness of 50. It called it overburden. And so we'll add the next strata below there. Coal, let's say it's about 8 feet deep, 8 feet thick. You can change your angles. So my overburden should be right around 65 degrees. I want my coal to be 85 degrees. And so what's nice about this is it's all interactive, and you instantly get to see your feedback up above in the preview. So this was written to simulate the old Pit Boss program more so than our cut in place. And this is just version 2, so this will also be enhanced in future versions. But the huge improvement this year is definitely the spoil bench, extended bench, and dozer bench. So I'll continue now. Let's see, our swell will be 20%. And you're also allowed to do some pre-strip or truck shovel thickness. So of my 50, let's increase that to 80. I have an 80-foot overburden, but I'm going to allow 30 feet of that to be pre-stripped. So that's just taken away, not thrown into the spoil, and I'm now left with 50 of overburden. Let's switch over to spoil bench. So now the drag line's over on the right. And each one of these methods has a settings option. So I can come in here and change my spoil offset, my bench height. Right now I'm 50 above. Let's go ahead and change that to say 30-foot tall bench. And it just instantly lowered this now 20 feet. I will allow some coal fender here of maybe 5. Just changing that. You saw now I'm halfway, or actually 5 up on the coal face. So now let's go ahead and add another seam. We'll add in an inner burden. We'll call it IB1. And below that, we'll call it C2 for coal 2. And we'll make that about 25 thickness, and this will be a good 8 feet thick as well. All right, so there's one possible range diagram. So the use for this would be sizing your pit width. Let's say I want to change it. Maybe I want to try 180 on my pit width. And you concentrate on these color-coded numbers. The blue numbers are fixed. That's your dragline range. The required, if it's red, that tells you it's out of range. I'm at a full 90-degree swing angle, and I need 519 feet of reach to get over here. So that's not going to happen. So maybe if I drop this down to 110, and this to 110. I'm down to 372. My dragline reach is only 286, so I'm still not going to do it. So you just play with the numbers, to size the reach or the range of your equipment. It's useful for finding your pit width or to find and size a drag line based on your digging methods. The extended bench, go back to spoil bench. And then if you're going to add another pass on the drag line, for example, I didn't show this. Let me go back to side cast. And you can add the second drag line pass. Choose the same unit. And that one should have a different offset. So that's how you do a multi-pass. You just keep adding different dragline tabs down below for each pass that it does. So we'll go ahead and take this and show you the output. It's nice that it's color-coded and everything's labeled, so you can see where each overburden and spoil goes. I'll go ahead and change those names, OB, OB2, and OB3. So the first one would be drawing it in CAD. I'll just hit the draw button and pick a point to draw a range diagram. So it puts it in AutoCAD as hatch, polylines, everything's labeled, and you can plot from there. Color-coded, so you know what dirt goes into what spoil. And then the other one would be your report. And it's a PDF report. This one is made up, it looks like, of 6 pages, and it's color-coded as well, showing you the dragline positions, each pass, and then the final page looks like that. So it's just a page-by-page output report you can plot out. Let me go back to that extended bench. There, that one worked. It didn't crash. So here's the extended bench. It also handles the rehandle amount and breaks that out and shows you where the rehandle goes. All right, that's fairly new. Like I said, 2013, you had just the one option, side cast. It didn't have all these options down below. It does also do a key cut here. But we'll go ahead and move on. Sorry about that. Let's go down to the list now. That was range diagram. Another new one, this has been asked for by several companies doing cast blasting and things, is an option to draw the blast holes and see them in 3D. We've always had blast pattern layout and drawn the points. But the new feature would be, go ahead and open that drawing. The new feature would be drawing those holes themselves, blast pattern layout. So in this example, let me go to Orbit and show you the 3D view of it. It looks like this bench has been shot, and you can see the shot in the empty pit. So I'll go ahead and lay out my next shot, and we'll take this bit of overburden and cast into the empty pit here. But I need to create my layout, and I want to see those holes in 3D then. That's the concept. All right, so I've got a perimeter. You first draw an outline, and then you also need to know the bearing. So my rows are going to go north 7 degrees east. My columns are going to go north 82 degrees west. And the same as the dip. I want the dip of my holes to go at that, we'll go 10-degree holes. So this is found under surface. Go to blast pattern layout. My ground surface, I'll choose that grid. It's blast pattern layout topo. My blast bottom, I'm just going down to a flat elevation 4600 to be consistent with what this is elevation-wise. We'll do 35 by 35 foot hole patterns. The vertical dip is the angle of my holes. I'll go 10 degrees, and that's from vertical. The dip direction, now this is important. You must put the number in between the letters. So I'm going to match this window over here. I'm going north, let's see, south 96 degrees west for the dip of those. That's the dip of the hole at 10 degrees. The row direction, I want to go starting here, my first hole, I want to go up to the northeast. So that's north 7 degrees east. The column direction, and this is why I labeled the bearing beforehand. Column is just going to be north 82 degrees west going that way. So I do want to do a staggered layout. You can do square or staggered patterns. We'll create the report, and here's the new option, is creating the lines and put those lines in this layer. And we'll create the points in drawing at the ground surface elevation. If you did blast bottom, they would all be just 4,600, but at least you would know where the drill has to hit. So we'll just hit OK. Select the blast boundary and pick the starting point. So the report formatter comes up, and you can see in the background it did draw the points already. Go ahead and just add everything over, and we'll go to Excel with that to look at the points themselves. So there's the list of holes, rows and columns. They're lettered by row and column. And it also reports out the XYZ of the top of the hole and the XYZ of the bottom of the hole. So you get both sets of points in your Excel spreadsheet. You could load this up to your drill then and with GPS and go drill them in. All right, and then the graphic part is here in the drawing. We do have the points, as you can see, but now if I go into my AutoCAD orbit and tip it down, this is what the improvement is. You can now see the 3D polylines of the blast holes themselves, and this is the 10-degree drilling from topo down to 4,600. And so we're going to add some more features to this, I believe, in the future. Things like measuring the distance between these polylines and the surface, and more analysis on the blast pattern layout. Okay, done with that. Moving down, a couple of pit commands have been added, pits or blocks. And one is to check for overlapping pits. That way you don't double dip any volumes. And then also a new improvement to the merge pits. So let's open up a drawing for that. While I'm opening the drawing, are there any questions?
No, there have not been any more questions.
Okay,
oh, wait, there is one. Just a sec.
Yep.
Can you move individual holes?
After the fact only. You can move the point and the line to the new location, but the layout is all automatic. They were all the same. But so if your first row is different, you would just do the first row, and then the additional rows you would do at a second step.
And then there's another question. Can you change the colors on the range diagram?
That I don't know. Let's go into the settings here. Options to label everything. Doesn't appear so, but I can check on that, and we should be able to add that feature. Good question. All right, so the first one, it's typical if you create pits and you're doing a lot of manual editing and redrawing, and you have partial mine pits, that you could have them cross over. These were laid out with matrix layout, so they're not going to cross. But I went ahead and corrupted a few of these and made them so they do cross. And then this new command will actually show you where, and you can go fix that. Under the pit polyline tools, they added the command here, check pit polyline overlaps. And it says select pit polylines to check. We'll just cross the whole thing. And it said it found 8 overlaps in the 176 pits that I selected. And it tells you the pit name, pit or block, and then also the coordinate where it does overlap. So it looks like the first one is 1,8 and 2,9 have a conflict. Let's go ahead and find those. 1,8 and 2,9. There it is. And if you zoom in on it, you can see what I did is I just drug the corner of one and overlapped it with the other. So it's just a way to find these kind of little sloppy drafting errors where the corners don't always match. Now, if it's a gap and there's an open space in between, it will not find that. You just won't get that volume. But for overlapping, you don't want to get the volume reported twice. All right, next one is just merging. You know, we've always had merge pit where you just pick in the big pit and then the little pit block, and it merges them those two into one. And now it's a little bit more automatic. And if I go down to merge pits, and I'll choose now by size. Merge pits with an area less than, and this is in square dimensions, so I'll go 25,000. Select all these pit blocks, and it looks like it merged. It says 4 of those. And so if you zoom in, you should see some leftover text where it merged them up. So it found this little triangle is less than 25,000, so it merged in with that previous one. Same with this one. It took it out and merged it over with the next adjacent block. and another one down here. But we still have the pick where you can go and manually do those as well. Okay, not real huge commands, but I just want to show them because they're fairly new for pit and block editing. So that brings us to the last topic, which I have highlighted here in gray, a whole new menu pull down in the underground module for solids. And what this will do is open us to a new market of underground hard rock and tunneling. And so let me open up a drawing for that. And this is a survey of an underground mine, and it's made up of survey points for the roof and floor, and then also of the rib on the side. So let me look at this in 3D. We'll go ahead and look at it in a 3D view. Still not the best view, so let's look at it straight from the front. There you can see it. I've got different points up on the roof, different points on the bottom, and then the rib lines. Let's do an orbit maybe. And so this is the requirement on what it needs. It needs a 3D polyline around the rib, and also then points for the roof and floor to make the surfaces. So you make a surface of the roof, surface of the floor, and then this is your rib line. And in the underground module, we'll go ahead and run some of these steps. Switch over to underground, and here's the new menu called solid. Things for making solid from surfaces, from section, draw, label, cross-section it, and then ultimately get the volumes. And then the bottom half are cross-section routines that we've brought over from the civil module into here just to save time from switching back and forth. These are similar commands you will find in the sections pull down. So let's go ahead and try this make solid from surface command. It needs tin files for the top surface, which I've pre-made from the survey, and the bottom tin. And then it says select the rib polyline. I'll go ahead and just pick that one. It's a 3D polyline. And we'll call this solid 1. Since it's written it, it's a separate file. And now we'll go ahead and draw that solid. Go down to draw solid. And there's solid 1. It's an MDL. Put it on layer solid 1 and drew it. It also handles internal polylines. So this is an internal polyline that I've drawn, also 3D, and that would be an exclusion. So that could be a hole in my solid. So before we view that, well, I guess we'll go ahead and view it first, and then I'll remove it and recreate it with that hole. Go to my 3D viewer window. And there is the 3D solid. And you can use the clipping plane to move it from left to right, and then that erodes what's inside, and you can see the bottom, the tunnel inside. All right, so let's go ahead and erase that. I'll just delete layer, and then I'll run it again, solid from surfaces, choose the top, and then the bottom, and then I'll choose both of those polylines. And I'll call this one solid 2. That'll have the exclusion. And then we'll draw it, and you should see, we'll call it solid 2, the opening, like so. And then we'll just take a look at that in 3D with the 3D viewer window. So these are just 3D faces, triangulations, and there it is. Okay, moving on. Next command is, we'll skip this one for now. This is the sections. That's over on the right. We just did draw solid. We're going to do label solid now. You have options for the height, any elevations, and we'll just take the defaults here. I haven't tried this one yet, but we'll go and choose the solid 2. Pick point to label. We'll just pick right there. Okay, it tells you that the height and the elevation, top and bottom of the underground cavity. And then I want to cross-section it. So now that you've got this solid created, I can do section solid. And let's grab this new one called solid 2. And it's going to make a section file, SCT file, and we'll call it solid 2 to match. station 0. So you could do this multiple times and just do a continuous cross-section file all the way down. We'll just start at station 0. My first point will be here, and I'll go across that opening and then back over to the right. So it made a cross-section that you see at the bottom, SCT file. And so you could draw that cross-section, or I'll just do the input edit section to take a look at it, solid 2. And there it is, station 0. And there you can see the exclusion, the hole is right here. So here's the first cavity, and here's the second tunnel on the right. All right, the next one. This one takes it, it's probably going to be more common, is make solid from sections. And this one looks for a survey down the actual, not the design, but the actual survey of the tunnel. And you can see I've got these cross sections every 50, and they're just 2D polylines on cross-section grids. And I made an SCT file out of those. So we'll go ahead and do that input edit section file one more time. And that would be solid from sections. There's station 0 to 4500, and I'll just go next all the way through it. You can see now the sides are not vertical. It does handle the overhangs, the circular cavities. That's not a problem. And so I've made then these cross sections, just an SCT file. Okay, exit. And it also needs the alignment. So I just drew a center line attached to the end of that previous solid. Stationed it so that should go all the way, those cross sections should go all the way up to 4450. So now we'll run the command, make solids from sections. Those are the two things it needs, is a section file and the alignment. And there's an option also to merge with existing solid, which is what I'm doing here. I'm continuing off an existing solid, or if it was a brand new one, you would just turn that off. But I'll just leave it on, hit OK. Section file to process. That was the one I just showed you, solid from sections. Centerline file. That's just the graphic center line of this red polyline you see there. Just your typical centerline horizontal alignment. And then finally, the solid file to read. This is what I'm going to merge into. And we can just merge into the solid 2, which is what we just made. And this is what the solid to write. And we'll just call this one solid 3. And then we'll draw it. Draw solid, solid 3. Put the layer solid 3, and then it just kind of tied into the existing solid and continued that down. Now we'll look at this whole thing together in 3D. Solid 2 and solid 3. Sometimes it's useful if you turn on the triangle edges, maybe not, or you could smooth the surface. This is your light source. You can control the different hatching. And then you also have the shading mode to shade the front and or the back.
So Grant, you have one question. Can you
Yep.
make solids from point cloud data from laser surveys?
You can, yes. The point cloud data would have to be arranged into a little bit more layerized based on what it is. For example, in these points I had here, they had points for the roof, points for the floor, and points for the sides and the ribs. And so hopefully that could be done with the point cloud data, and then you could either do sections from that and make a solid, or we could do the first one, which I did was solid from surfaces. Might not be as automatic, but it could be done. And if we had some of those point cloud data, we should be able to try it and add that if it doesn't do it. But now I just want to show this clipping plane. You can see here's my cross section. As I move the clipping plane down the tunnel, there it goes. Exact duplication of those cross sections you saw. And then it tied right into the existing solid. All right, the last thing then would be the volume. And that's this command, calculate solid volume. I'd like to get the volume of this solid 2 that you see there. Calculate solid volume. We'll grab solid 2. And it also needs a pre-calculated model. This could be a stratified model. It could be a block model. And I just have this one called rock pre. And it could give you stone type or volume of different seams or strata or grades. But in this case, I just called it all rock. I'll move it over and display. And there's the whole thing was just rock. And the total volume is 15,000 cubic yards. And I just distinguished that as all key and all ore, 15,000 cubic yards. But you could break that out by different grades too. And that's about it for the solids menu. This is the first year for this, so if you have any suggestions or improvements on this once you get into it, let us know and we can definitely add those. So with that, it looks like we've got to the end of the list of the geology and mining commands. But when you do download the 2014, you'll get this, and you should be able to find this CARLSON 2014 improvement list. That is 5 full pages of new commands for all the modules and general commands as well. So with that, we can answer any final questions, and thank you for attending, and let us know if you have any questions.
We have a question, can seams in the pre-calc intersect the solid?
Yes, definitely. That was what I was showing with the calculated volumes. I just had it all as rock, but if we added a seam halfway down, that would show up. And this, if I go back to the 3D viewer window, it brings in the solid itself. And then the reason I just reported out only one strata was because if I bring in my surfaces, add a surface, I had in my pre-calculated model, I had top +5. Let's make that transparent so we can see the solid behind it. And then I'll add the next surface, which is just a bottom. Bottom I did -5. So that was what defined the rock zone. And then if you had different seams that crisscrossed inside there, it would definitely break out the tons and volume by different material or seam name or grade. But the transparency is kind of nice, definitely for the solids and the ore body modeling. Okay.
And there's another question. Any thoughts of being able to create surface solids? And he says surface solids for surface mine reserves.
I guess I'm not sure what they mean by surface solids, because all of our surface mine reserves are done on grids or tins, which are surfaces already. Maybe we need some more description on that comment. I'm not sure what he's referring to.
I guess the surface solids for surface mine reserves. That's how he explained. Wait a second.
Oh, well, maybe they want to take the solid and run surface mine reserves on it. Okay, no, that hasn't been done yet. It just does the one that I showed, which was calculate solid volume. But I see what they're looking for. Maybe they want to get the chemistry and everything else reported out too. That's a good suggestion.
So that's the last question.
Well, thanks again for attending. And so let us know if you have any questions or if you need your 2014 serial numbers, because they have been available now for a couple of weeks. So with that, I'll go ahead and end the webinar.